Yep, kia ora everyone. Thanks for joining into my presentation and everyone else's. Appreciate you taking the time. So my presentation is on fish passage through crossing structures in Tairoa Forest. Let's go to the next slide. Yeah, so the goal of my presentation is to understand the factors that influence fish passage and how we can prioritise structures for this. There's three steps. The first one is why is fish passage important? We'll look at the law and New Zealand native freshwater fish species and how they have different swimming abilities. Number two, how do crossing structures interact with each other in the environment? We'll look at the length of upstream habitat and the interaction of structures within a catchment. And number three, how we can prioritise these structures for fish passage. And finally, I'll do a summary with my recommendations. So why is fish passage important? First of all, it's amazing that we're still having this conversation 38 years on from a law on fish passage being put out by freshwater fisheries regulations. And then even in 2017, the NESPF, which we're all a lot more familiar with, also states that every crossing requires fish passage. New Zealand native freshwater fish. We have a diverse and complex population of freshwater species, 74 species of which 51 are native. Most people know a few of our native species like the eel and whitebait, which are important kayaka species. However, there are many more equally important species which are less well known due to their often small size and rarity. Many of our species are migratory, often spawning out in the ocean before traveling upstream. And a lot of them, so 70% are endangered or threatened due to loss of habitat from wetlands being drained and large-scale deforestation. So we in Forestry have the responsibility and opportunity to help with the conservation of these species because we have some vital habitat, and cutting this off due to a lack of fish passage can have major implications. So species have different abilities. The first type are climbers, such as this redfin bully. They can stick to the wetted edge using surface tension to travel up fast-flowing waterways. Anguilliforms are eels and can absorb 50% of their oxygen through their skin, and this can allow them to travel over land. Swimmers are the weakest at getting up waterways as they rely on only the velocity they can generate themselves. And jumpers, non-native species such as trout and salmon can jump up obstacles to save energy. If we understand the different abilities, we can get an idea of what would cause fish passage loss and what features need to be included in our design to ensure that species can pass the structures. So the key limitations to fish passage are vertical drops, such as what you can see there. The laminar flow caused by that vertical drop can't be climbed by any fish species. And shallow water with high velocity can also limit, especially swimming species, but within pipes, but also can be an issue on forwards. So my study area is Tairoa Forest in southern Coromandel with Whangamatara at the bottom there and Pawanui at the top. So there were 35 crossings in this forest, 12,600 hectares of forest, 9 catchments with over 600 kilometres of potential freshwater fish habitat. The majority of the structures were culverts, as you can see, and of these culverts, 17 were perched. So how do structures interact with each other in the environment? Structures occur in catchment networks where potentially all that habitat is accessible by fish. So we can have a look at how much habitat can be affected due to the structure being there. So within GIS, I measured the length of the habitat for the whole catchment. So for this one here, it was 12.6 kilometres, and the total for Tairoa Forest was 600. And then I measured upstream from every crossing. So you can see there upstream from that 104, there's 8.5 kilometres of habitat. So the total potential upstream habitat above all structures in Taiaroa Forest was 120 kilometres, which is 20% of the total area. And this is the area that's potentially inaccessible due to fish passage issues. So structures occur in an upstream flowing network. So a fish migrating upstream has to pass the bottommost structure first, obviously, before it can reach the top. So therefore, the structures closest to the ocean are most important, and we can give them the network position of the number of structures above them. So then we can start to prioritize which structures we need to look at first. So how do we prioritize for fish passage? The first step is identifying fish species present. Two good ways to do this are using eDNA in the freshwater fish database. eDNA is relatively cheap, and it's pretty sensitive at picking up what species you have in your waterway. And it's also really good to use to monitor the success of your structures. Knowing what species you have, you can look at the conservation status and the swimming ability of the species you have and design your structures accordingly. So we've already talked about this potential habitat loss, but within Taiaroa Forest, here are the top 6 structures with the most potential upstream habitat. So that top one there, 34 kilometres, and the next 2 are also in that 20 to 30 kilometre range. So you can see that some structures can have a huge effect on potential habitat for fish. And you can also see in that table that 4 of the 6 are fords, and none of them are culverts, which is interesting, but probably unsurprisingly with that amount of habitat that these waterways are quite high flowing. So yeah, we can really see the importances of fords when we look at fish passage. So this is that Wharekāua catchment, all the structures in that catchment in the matrix. So if you look from left to right, you'll go from least to most important when it comes to fish passage. So on the right, you can see that 22 kilometres of upstream habitat with 10 other structures above it. And you can see how all these structures interact with each other. So this ford here is number 54, and it has 8 kilometres of habitat above it. And you can see it's pretty shallow, fast flowing. So this could potentially be causing issues for fish passage. So finally, remember, fish passage is a legal requirement. So my recommendations for this is to understand what species you have in your area and understand what other structures you have and how they interact with each other. And remember that good fish passage can look very different at different sites, depending on the structure type you have, the species that you have, the habitat around it, the size of the waterway, and a number of different factors. And also remember, culverts aren't the only crossing type. Fords can be very significant, and while it's very tempting to stick some mussel spat ropes or baffles in a culvert to improve fish passage, this might not be the most effective at improving fish passage within your forest. So yeah, that's all I've got. Thanks, everyone.
Thank you very much, Drew. So it was exactly 8 minutes and 9 seconds. So you can tell that he was very well prepared in his presentation, nicely targeted. Open to questions, yeah.
Nice job of identifying the need to change through the significance and relevance, and through different methodology and all that sort of stuff. So you did a great job on that. You highlighted the fact that there had been no change in 38 years, which is always surprised me. But what you have done, and I'm interested in your opinion, is why there has not been change to date, given that there is a clear legal requirement to have changed in the last 38 years. So, and the reason I'm asking that question is because you made some nice recommendations, but the barriers to them being used is that question, why has it not been changed?
Okay, so sorry, if I can keep the questions a little bit short because I need to repeat them for our Zoom audience. So a very good question by Mr. Trevor Best here with regard to the fact that it's been law for so long. So his question really is, you know, why, really good presentation, nice recommendations, but why haven't we been able to make these changes over this period of time? Asking for Drew's opinion on that.
I think there's probably a lot of things that come into that, but I think the main one is that the law is pretty weak. The freshwater fisheries regulation has got like a $4,000 fine or something, but I don't think there's ever been a fine handed out for it. And also, there's no, like, fish passage is like what I've said there, is it looks so different. It's pretty hard to judge without like quite a lot of science going into every crossing. So yeah, I think the main issue is just the like lack of clarity within the law, but then also it's difficult to have a really black and white law because it looks so different everywhere.
These companies have been certified for 20 years.
Okay, so the comment by Mr. Britt Gilmore was that it's an FEC requirement to have fish passage. So we've got need to protect threatened species. So it is. So all those companies are FSC certified. So again, it's probably just highlighting a potential disconnect between even some of our certification systems and what's actually out there.
I think there's a reputation there, though. That's what I'm trying to get to. Reputation is basically you need a process of what you just described.
Okay.
To simplify, to get this to the point where people do it on a consistent basis.
So I'll just turn Mr. Best's comment into a question for Drew. Is this the right, like your recommendations, is that the right approach for making this a more formalized requirement within the forest industry?
I don't know whether you can turn my approach into a law, but I think for Brett's comment on FSC, it's a good step for something like that to show that you are trying to prioritize for your threatened species, because, you know, like in Rainier and Bay of Plenty, there's 120 crossings, so it's pretty hard to, you know, have the resources to check all of them. But if you have some system of deciding which ones are the most important, which ones have the most endangered species, and yeah, have the most effect on a catchment, then that's probably a good step for showing that you're trying to do the right thing.
So just one more question maybe from our Zoom audience, or I'll just see if there's a Zoom audience question. Otherwise, I've got one from Mr. Wells, Mr. Barry Wells here.
Yeah, I was just wondering if there was any consideration to the perch structures actually protecting habitat further upstream, so stopping predation by trout.
Okay, so Barry's got an interesting question around perched structures actually protecting upstream habitat by restricting predatory type species from migrating up above our culverts.
I think for new structures, like the trout are probably already up there, so creating new perch structures is maybe not the answer. But I think it goes back to surveying what species you have.
Yes.
And if you do identify species that need protecting, then yeah, it's probably the right thing. But I think that's one of the key takeaways from this, is you really need to understand what you have and what they require for like habitat, maybe protection, and also what they require for fish passage.
Okay, with that, thank you very much, Drew. Much appreciated. And yeah, move on to the next presentation.